Assalamu alaikum everyone. In today's video, we will discuss about a lead code problem. The problem number 136. Title of this problem is single number and it is a problem of easy category. Let's see the problem statement. Suppose you are given a non-empty array of integers nums. Every element appears twice except for one. That is, each of the element in num has a matching pair. However, there is a single element that doesn't have any matching pair. You have to find that single element. Let's see some examples. In example 1, our nums array contains three elements 2, 2, 1. If you notice, you can easily say that 1 doesn't have any pair, so our desired output will be 1. In our second example, you can see nums contains 5 elements and they are 4, 1, 2, 1 and 2. If you notice, you can easily see that 4 doesn't have any pair, so our output will be 4. Now what will happen if your nums array contain only one element? You can easily guess that this single element will be our output. So our output will be 1. Now how are we going to solve it? The easiest method to solve it is using sort. Suppose our nums contain 5 elements for 1, 2, 1 and 2. If you sort the elements in the nums array, they will be in kind of this order, that is 1, 1, 2, 2 and 4. You can easily notice that the matching elements have come to the consecutive places. So, if you simply traverse through this array, you will see that each of the element has a consecutive matching element. However, there will be one and single one element that will not appear in pair. So, this unpaired number will be our output. Now, let's see the code in C++. This is a sample code, but however, I'm not going to explain it because this is not the purpose of this video. Let's analyze its time complexity. So in this code, we have used the built-in or function sort that has been provided us with C++ compiler. So this sort function usually sorts an array or any kind of sequence of numbers within n log n time. Though we have traversed the array after sorting them, but the sort will be dominating, and so the most of its time complexity will be dependent how the sorting algorithm works. In this case, the sorting algorithm works in big O of n log n, so our time complexity will correspond to it. Now what will happen if I ask you to solve this problem in big O of n, that is in linear time? If you think for a time, you may come up with using the hash map. So let's see this second method using hash map. Let's revisit our previous example where our nums array contained 4, 1, 2, 1 and 2. For hash map, we will use the built-in C++ map function, map standard template library, where the first element of our pair will be the array member and the second element or the member of each of the pairs will contain its occurrence, that is how many times it has appeared in the nums array. So if we store this nums array element into the mymap, then we will see that they will be stored there kind of this way. So if you notice, you will see that they are stored in pair and the first element of the pair will correspond to the element or the unique elements that has been present into the nums, and the second element will correspond to how many times it has appeared in the array. So in the first pair, it is saying that 2 has appeared twice in the array. The second pair responds that 1 has appeared twice in the array. However, the last pair is saying that the element 4 has appeared only once in our nums array. So the pair with occurrence 1 will be our output. It is as simple as this is. This is the sample code of this problem using hash map in C++. However, I am not still going to explain it because this is not either the purpose of my video. Before proceeding, let's analyze its time complexity. So we know that we can store any element in map or and as well as insert any element in map as well as retrieve it within a less than big O of n time, that is less than in linear time. So here the dominating part will be this loop where we are traversing each of the element of the array. These two loops actually. So our time complexity here will be bigger of n. Now that's linear. Now comes the space complexity. If you see this code, we have used an extra variable that the size depends on how many elements there are in nums. If the nums element contain in if the nums array contains n elements, then you can easily guess that in my map there will be in total of n by 2 ceiling values because almost n by 2 elements does appear in pair in nums except one. So we can say that the size of my map depends on how many elements there are in num. So we will say that our time complexity here will be bigger of n, that is the size of the map. Though we have solved the problem in linear time, but it costs of using a huge amount of space. So what will happen if I tell you to solve this problem using only constant amount of extra space? That is, your space complexity can take 6 big of 1. I know it's getting kind of annoying. However, learning this will not be a waste of time. This next method will be a bit of inconvenient, but see what will happen. In our third method, we will use bit manipulation. For this, we will use a bitwise operator named the XOR operator. Before proceeding, let's gain some insight on XOR operator. And to tell you that we will only discuss some of the properties of XOR operator, but we will not go deep and see that how and what XOR operator works. So XOR is actually a binary bitwise operator. What does it mean? This means that each time the XOR operator operates on 2 bits. So if the 2 bits are the same, then it will give output 0. And if the bits are dissimilar, then it will give output 1. Let's see the examples. In our first example, the XOR operator operates on the bit 1 and 0. We can see that both of the operands are not the same, so our output will be 1. The second example corresponds is similar to the first example. The third example, we can see that the 2 bits are same, so our output will be 0. The fourth example is similar to the third example. Now, what is the output if we calculate the XOR of 42 and 58? We know that in computer architecture, every arithmetic operation is done in binary mode. So if you try to calculate it in using computer, so the first thing that our processor will do is to convert this number into their corresponding binary modes. So 42 and 58 will both be converted to their binary modes. Now how am I going to calculate the XOR of these two numbers? First, let's assume that we are calculating the XOR operation from the leftmost 2 bits. So let's consider the leftmost pair of bits. In our leftmost pair of bits, we can see that the both of the pairs bits are same. So our output will be 0 if we do XOR on these 2 bits. Then we will move to our next bits. Here we can also see that the 2 bits are 1, so our output will be 0. We will continue this process. We will move left again. Now here you can see that these two pair of bits are dissimilar, so our output will be 1. Now when we reach our rightmost pair of bits, we can see that the bits are same, so our output will be 0. So if we take 42 and 58 and calculate their XOR, we will get this kind of output in binary. When giving output, the processor will again convert this binary to its to its to its corresponding decimal value, and it will be 16. And this is our solution. Now what will happen if we calculate the XOR of 0 and 58? Again, these two numbers will be converted to their corresponding binary modes, and after that we will calculate the XOR from the leftmost pair of bits. Here the leftmost pair of bits both are 0, so our output will be 0. Then if we move left, then we can see that the bits are dissimilar or different, so our output will be 1 in this case. We will proceed until we reach the rightmost pair of bits. Here the rightmost pair of bits are 0 and 1, which are not same, so our output here will be 1. So this is our corresponding output if we take the XOR of 0 and 58. You can easily notice that the output is similar to 58. Okay, so here's the interesting fact, that is, if you take XOR of any number with 0, then the number will be unchanged. Okay, now what will happen if we swap the operands of XOR operator, that is, what is the relation between 42 XOR 58 and 58 XOR 42? In our previous slide, we have already calculated 42 and 58, and the output was 16. I leave it to you to calculate 58 XOR 42. If you calculate, you will find the interesting thing that the output remains the same. So here's another fact, that is, XOR operator, the XOR operator maintains the commutativity, that is, if you swap the position of operands, the output will not be affected. Now, what is the output of taking XOR of two same numbers? I'm leaving it to you. Here you will find another fact, that taking XOR of two numbers will give the output 0. Now let's dive into the problem solving. At first, see a sample code in C++. Here, at first, I am taking an arbitrary variable named result and initializing it with 0. After that, I am traversing through the given nums vector or array, and each time I am encountering an element in nums, I am just modifying result by taking XOR with the corresponding nums element. After iterating through all of the numbers of the nums array, I will simply return the result, and this result will contain the single number. Now, how it is happening? Let's see our example where nums contain three elements, 2, 2, and 1. First, we will assume the arbitrary variable result and initialize it 0. Then we will iterate through all of the elements of nums. So when our first iteration occurs, I will be 0 and result will be replaced with result XOR the first element of our given array. At first result was 0, so result will be replaced by 0, and the first element of nums is obviously 2. So after the first iteration, result will be 0 XOR 2. Now let's move on, and when I is equals to 1, we will again replace our result by taking XOR value with the second element of our nums, that is 2. So here, after the second iteration, result will be 0 XOR 2, that is the previous value of the result, and XOR the second element of nums, that is 2. In our last iteration, we will similarly replace result by taking XOR with the last element, and the last element is 1. So after all of the iteration, our result will be like this thing, 0 XOR 2 XOR 2 XOR 1. Now let's calculate result. So result was kind of this thing, 2 XOR 2 XOR 1. So let's assume the first two elements. In this box, you can see that the first two elements are same, and in our previous section we have already discussed that if XOR operates on two same number, then the output will be 0. So in our second line, we can replace this expression with 0 XOR 1. Now we can use another fact, that is, taking XOR with any 0 value will keep the other operand unchanged, that is, our output will be 1, and you know that this 1 is the unpaired number. Okay, let's revisit another example. So here now our nums array contains 5 elements, that are 4, 1, 2, 1, and 2. You can as easily see that our output here will be 4. Now let's see how our code is calculating it. Similar to before, we will assume our result and initialize with 0. iterate through all of the elements of the nums array and replace result with taking the value of XOR with the corresponding nums element. At our first iteration, result will be of 0 XOR 4. After the second iteration, it will be 0 XOR 4 XOR 1. Similar to second and third example iteration, at last at the fourth iteration it will be kind of this thing: 0 XOR 4 XOR 1 XOR 2 1 and 2. Now let's see how is result giving the output 4. So here at first result is containing 0 XOR 4 XOR 1 XOR 2 XOR 1 XOR 2. Let's see the first two numbers. Here you can see that this XOR operator is operating on a 0 and a non-zero number. So as one of the operands is 0, so the other operand will remain unchanged and this will be the output. So here 4 will be the output. Now let's revisit these two operands. This time XOR is operating on 1 and 2. Here we will use another fact, that is we will swap the positions of the operands, and we know that swapping operands will not change the output. Now after that we will consider the operands on this box. Here these both of the operands are the same, so our output will be 0 in this case. Now let's assume the last two operands or the last two numbers. So 0 XOR 2, any XOR with 0 value will remain the other operator unchanged, and that will be the output. So this time this output will be 2. Now in our next step we will consider 2 and 2, as both of the operands are same, so our output will be 0. 4 XOR 0, taking XOR of any value with 0 will remain, will keep the other operand unchanged, and the other operand will be output. Now 4 is our desired output. Let's see the time complexity. If you see our previous code, we have only iterate through the array once. So if the element of the array is n, we have to go through all of the n element only once. So our time complexity will obviously be bigger of n. Next, in the space complexity, we have only take a single variable result as our extra space. So obviously this time our space complexity will be bigger of 1. So thank you everyone for watching this video.